Hello there and welcome back to Nature in Code. In the last lecture, we wrote our first line of JavaScript. In this lecture, we are going to implement Hardy-Weinberg in JavaScript. So before we do that, I would just like to revisit very quickly what Hardy-Weinberg states. Hardy-Weinberg states that given certain allele frequencies, your population should be at Hardy-Weinberg frequencies for the genotypes. So your genotypes should be at very specific Hardy-Weinberg frequencies. If they're not, then they're going to be within one generation. So just notation-wise, I'm going to rewrite this idea here by starting with the general notation that the frequency of the A1 allele is going to be denoted by the variable p. This is very standard in the literature. Consequently, the frequency of the allele A2 is going to be denoted with the variable q. And of course, because there are only two alleles, those two have to add up to 1, so q equals 1 minus p. And of course, p equals 1 minus q. Now, the Hardy-Weinberg frequencies for the genotypes are as follows. The genotype frequency of the A1 is the probability that you pick an A1 allele, which is its frequency, which is p, times the probability that you pick another A1 allele, which is again p. So that is p squared. The Hardy-Weinberg frequency for the heterozygote is p times q, so that's the probability that you first pick an A1 allele and then an A2 allele, plus the probability that you do this in reverse, so first pick an A2 allele and then, oops, sorry, that should be times, not a plus. So first you pick the A2 allele and then you pick the A1 allele, so q times p, which is of course the same, so that's 2pq. And then finally the frequency of the A2 genotype is going to be probability that you pick the the A2 allele, which is q, times the probability that you do this again, which is q squared. So these are the three frequencies, the Hardy-Weinberg frequencies, in a population that has these allele frequencies, p and q. Now these three, of course, add up to 1 as well, because those are the only three genotypes that are possible in a diploid population. And just to demonstrate that real quick, so your total sum of the three genotype frequencies is p squared for the A1, 2pq for the A1, and q squared for the A2. Now keep in mind that we could rewrite q as 1 minus p. And then if we do that, we can express this whole thing in all just p's. So this would be p squared plus 2 times p times 1 minus p. Okay, so I replace that q here with 1 minus p plus 1 minus p, yeah? So I replace that q here with 1 minus p squared. If we expand that, we get p squared plus 2p times 1, which is of course 2p, minus 2p times p, which is 2p squared, plus 1 minus p squared, which is 1 minus 2p plus p squared. And now if you look at this expression, let's look at the p squares here first. We got p squared minus 2p squared, which is minus 1p squared, plus p squared, which is 0. So these three terms here cancel each other out. Then we have here plus 2p and here minus 2p, so these two cancel each other out, and all that remains is plus 1. So this whole thing equals 1. And that's what we wanted to show. The frequency of these three terms is, the sum of the frequencies is 1. All right, so enough Hardy-Weinberg theory. Let's implement this in code. So I'm just going to go ahead, going to go over here to my text editor, and I'm going to start from the document that we created here and use this as a template. So first of all, I'm going to get rid of this hello world here. We don't need that anymore. And we don't need this line of JavaScript anymore. And I'm going to delete that. Okay. So what I would like to do is I would like to start with, again, just like in the example in an earlier lecture, I would like to start with the frequencies of the genotypes. Then from those, calculate the allele frequencies. And then from that, calculate what we would find in the next generation. And let's just do this for 5 generations. So that's the goal of this and the follow-up lectures, to implement this in JavaScript. So I'm going to use numbers that are equivalent to the example that we used before. So I'm going to assume that we have 15% of the A1A1 genotype, that we have 35% of the A2A2 genotype, and then 50% of the homozygote, the heterozygote A1A2. All right, so let's start by implementing this in code. So I'm going to do this by saying var A1A1 equals 0.15. So those are the 15% of A1A1 genotype. And the other homozygote, A2A2, is at frequency 35%. And finally, the A1A2, which I'm going to store here in a variable A1A2. Well, I know it's 50%, but let me just be a little lazy here and calculate, have JavaScript calculated. So it's going to be 1 minus the sum of what is stored in these two variables. All right, so let me walk you through these lines here. What happens here is, first of all, we are defining 3 variables. And a variable is really a key concept in JavaScript. Basically, it's saying, I have this variable here, I'm going to give it a specific name, and I will, at one point or right away, assign it a value. And then I can later retrieve this value just by calling the variable's name. So that's something very generic and something that you use all the time. So in this case, we are defining a variable called A1A1, and we are assigning it the value 0.15. So a couple of things to be noted here in terms of syntax. First of all, there are only 2 rules about the names for JavaScript variables. The first is that it has to start with an underscore or with a letter, and can then be followed by underscores, letters, and numbers. Okay, but the key takeaway here is don't start your variable names with numbers. That is illegal in JavaScript. So A1 starts with A, so that's perfectly legal. The second rule is you can't use a keyword that's already predefined by the JavaScript language. And it's unlikely that you would do this by accident, but I still want to show you a list of JavaScript keywords, and you can just look this up by Googling JavaScript keywords, and you will find various websites like this one that will give you a list of the keywords. Now, after you've had a bit of exposure to JavaScript or any programming language, you would realize that these are keywords that are used in the language. I mean, if you learn Python or Java or any other language, you know, many of those words would be exactly identical. These are just, you know, keywords that are used in many programming languages nowadays, and so it's very unlikely that you would use them anyways. But just in case you're uncertain if a certain variable name is problematic because it's a keyword, just Google it and try to find whether the name is actually a reserved keyword. All right, back to the code. The second thing I want to notice here is that we assign a value to a variable using this equal sign. And finally, we end a line by using this semicolon here. Now, technically, you might be forgiven to forget that. JavaScript will actually automatically fill that in for you in the background. But please try not to do that. And certainly don't do it on purpose. You could write this exact same code without the semicolons and it would still work. However, it's bad practice because it might down the road introduce very subtle, very hard to find errors. And so I strongly, strongly recommend that you terminate each line with a semicolon like this. And then finally down here we're just using basic arithmetic, using the just normal operators that you would use in math, in this case minus and plus. And we can group things together by using parentheses. All right, so these are the first 3 lines. They are fairly straightforward. Now, there's one more thing I want to do before we move on. And that is, I would like to calculate the allele frequencies. So I'm going to go ahead and define another variable here called p, which is the variable that will store our A1 allele frequency. And that is simply A1 plus whatever we have in A1 A2, so the heterozygote, but just half of that. And then again, I'm going to be quite lazy and I'm going to define Q as simply being 1 minus P, which we know is correct. Okay, so 2 more lines, a few more things here to say about those lines. The first is I'm using a very short variable name here, and that's okay in this example because P and Q are these, quintessential variables for A1 and A2. And if you look at any population genetics textbooks, you will probably find these exact same variables. In general, however, I strongly recommend that you use more verbose names that actually really say what exactly the variable means, what sort of value it represents. So when you code, you often just want to be fast and you think, yes, I have this variable and I want to store a value in it, so I'm just going to call it X. But then if you look at this code, 6 months down the line, it might be very hard for you to remember what exactly you meant by X. However, if you call it genotype frequency, then you look at this line of code and you instantly see, this is the genotype frequency. So please try to be fairly verbose in naming your variables and give them names that are actually representative. Now I think here in this small example, we're fine, but just keep this in mind. The other thing I want to mention here is you see again these parentheses, and now you could of course say, well, but I wonder, is that necessary? Does JavaScript algebra just follow the general algebraic rules? Yes, absolutely. So division would occur before addition. So A1, A2 would be divided by 2 before the result of that would then be added to A1, A1. However, I personally prefer to group things that belong together in parentheses. It makes it just a little easier for me to read, and I bet it makes it a little easier for you as well. So I'm just using these parentheses here for visual aesthetics. And one final thing, so these white spaces here, they're not necessary. You could write it like this if you wanted to. Again, I think that's actually harder to read, so I'm just going to use these white spaces here. Same with indentation, as we discussed previously. You could do it like this. You could add as many line breaks as you wanted to. However, I'm a big fan of easy to read, easy to understand code, because later you will go back to this code, or someone else might be looking at this code and will be thankful, or you might yourself be thankful for whoever wrote easy to read code. All right, so if we save this and now we'll go over to the browser and reload this, first of all, the hello world would disappear because we removed that, but now there's nothing here in the console. Why is that? Well, if you look at the code, we didn't instruct JavaScript to write anything into the console. These things here will be calculated, but after they're calculated, that's it. They're gone. We're not printing anything into the console, and we're not doing any further calculations with this. In the next lecture, I want to do this. But just to wrap up, so we learned how to define variables, what they are, how to do basic math like minus and plus and divisions, and how to sort of write aesthetically pleasing JavaScript code, meaning that it's easy to read, and later when you get back to it after a long break, you find it easy to read. All right, let's continue in the next lecture. See you there.